Let us begin with an introduction to the OpenAI Embeddings API. This lesson introduces the OpenAI Embeddings API. It explains how to use the OpenAI API for text embeddings in Python. No prior AI or coding experience is necessary to follow this lesson. Embeddings convert text into numerical form so computers can understand it. By the end of the lesson, you will be able to run your own embedding example. Running the cell now. Now let us move on to why embeddings matter. Great work! Now let us understand why embeddings are important. Why use embeddings? Computers cannot understand text the way humans do. Embeddings are vectors that let computers compare texts by meaning. Embeddings help with search, recommendations, and more. This is a basic building block for many real AI projects. Running the cell now. Next, let us talk about installing the API library. First, let us make sure we are not distracted by warning messages. We add a comment to explain we are hiding warning messages for clarity. We import the warnings module and turn off all warnings. Import numpy as np. We set the random seed to 42 for reproducibility. This line reminds us that clean output helps us focus on the important code. Running the cell now. Here, we set up our coding environment by suppressing warnings and fixing the random seed for reproducibility. Although no visible output appears, these steps ensure our embedding computations will be consistent and error-free, supporting the reliable comparison of text meanings in later lessons. That is it. Now our notebook will not show any warning pop-ups. Let us make sure you have the OpenAI library installed. Installing the OpenAI API library. To use the API, we need the OpenAI package. If you do not have it, run pip install OpenAI in your terminal. Once installed, you are ready for the next step. Running the cell now. Now we can begin working with the OpenAI API. Let us start by importing the libraries we need. This comment explains we will import our core libraries. We import the OpenAI module. This is what we use to connect to OpenAI's API. We import OS, which is a basic Python tool for working with our system environment. Here we explain OpenAI will help us make requests. And OS will help us get our secret API key safely. Running the cell now. This code sets up the environment by importing the OpenAI package and the OS module, which is essential for accessing API keys securely. Although there's no output to display here, this step is crucial because it prepares us to authenticate and interact with the OpenAI API in the following lessons. Notice that importing these libraries correctly ensures smooth execution of future API calls. Now our basic building blocks are ready. Now we need to tell Python how to talk to your OpenAI account. We mentioned that this comment is about secure key setup. We pull the API key from our environment. This means it stays secret. We create a new OpenAI client using that API key. We will use this for all requests. This gives our program a way to talk safely to the OpenAI service. Running the cell now. This code sets up your OpenAI client by securely loading your API key from environment variables, preparing you to make authorized requests. Notice there's no visible output. This is intentional, as the code's goal is to establish a connection behind the scenes, ensuring your key stays private before moving on to calling the API. Now you can use OpenAI just like any other Python tool. Let us understand what embeddings really are. What are embeddings? An embedding is a list of numbers that represents meaning. Similar text has embeddings close together. Unrelated text has embeddings far apart. With embeddings, you can find similar texts, cluster topics, and power smart search engines. Running the cell now. This is the secret tool behind many AI features today. Let us walk through how to create embeddings for several pieces of text. This comment gets us set up to create our first set of embeddings. We define a list named texts. We add our first string about OpenAI. We add a second string about machine learning. We add a third, unrelated string about bananas. Closes the list of texts. We call the OpenAI Embeddings endpoint using our client object. We specify the embedding model to use, here a small, fast model. We pass the list of texts as input to embed them all at once. Closes the embeddings creation function call. We print out how many embeddings we created based on the response. Running the cell now. This output confirms that the embedding model processed all 3 input texts, generating a vector for each. Notice the count matches the number of texts, which is key because each text requires its own embedding to capture its meaning. This step is essential for comparing or clustering the texts based on their embedded representations. When you run this, you will see how many embeddings were returned for your texts. Now let us see what one of these embeddings really looks like. We comment that we are about to look at a single embedding. We grab the embedding vector for our first input text. We print out just the first 10 numbers so you can see the format. Embeddings are long lists of floating point numbers. Each number helps describe a tiny piece of meaning. Running the cell now. This output shows the first 10 numbers of an embedding vector, illustrating that embeddings are just lists of floating point numbers. Notice the small decimal values, both positive and negative, which together capture the semantic meaning of the input text. This helps us understand how embeddings represent text as numeric vectors for comparing similarity. Notice the vector looks like a list of decimals. Each item stands for something unique. Great! Now let us see how to compare the meaning of different texts. Comparing embeddings, finding similarity. You can measure how similar 2 texts are by comparing their embeddings. The math term for this is cosine similarity. Higher values mean more similar. Lower values mean less related. Let us see this in action. Running the cell now. Now we will show how to measure similarity. We will now add a way to measure how close 2 texts are in meaning. We begin with a comment stating we are using simple cosine similarity. We import math to help us do some calculations. We define a new function named cosine_similarity. We find the dot product of our 2 number lists. We find the length for the first vector. We find the length for the second vector. We divide the dot product by the product of the lengths. This gives a number between -1 and 1. Running the cell now. This code defines a function to calculate cosine similarity between 2 vectors, which is essential for comparing text embeddings in this lesson. Notice it computes the dot product and normalizes by the vector magnitudes to produce a value between -1 and 1, where higher values indicate greater similarity. This sets the foundation for measuring how closely 2 texts are related based on their embeddings. This simple math lets us see how close our texts are in meaning. Let us test how similar our texts really are. We add a comment that we are computing similarities. We compare the embedding for OpenAI with machine learning. We compare the embedding for OpenAI with bananas. We print out the similarity for OpenAI versus machine learning. We print out the similarity for OpenAI versus bananas. This will help us see which texts the model thinks are related. Running the cell now. Here, we see cosine similarity scores measuring how related the first text is to the second and third texts based on their embeddings. The higher score of 0.48 for the first versus second text indicates moderate similarity, while the low 0.04 for the first versus third text suggests they are largely unrelated. This demonstrates how comparing embedding vectors can quantify text similarity effectively. If your scores match what you expect, our code is working. Now some good practice tips when working with embeddings. Best practices for OpenAI embeddings. Use small models for speed and cost unless you need higher quality. Remove extra spaces and odd characters from your text for better results. Store embeddings to save time and money later. Do not use full books, use short sentences or paragraphs. Never share your API key. Running the cell now. Following these habits keeps your AI projects running smoothly and safely. Now, let us add code that helps us handle errors safely. We add a comment to explain we are adding error handling. We start a try block. This is Python's way of trying to run code that might have a problem. We call the embeddings creation method inside the try block. We specify the model to be used for the embedding. We provide the input text as a list with one string. We close the function call. If the embedding call succeeds, we print a success message. If there is any error, we catch the exception and print an error message. Running the cell now. This output confirms that the embedding request was successful, indicating the small model handled the input without errors. Notice how the code structure anticipates potential issues, which is essential for robust API usage in real projects. This aligns with the lesson's emphasis on using appropriate models and best practices to efficiently get embeddings while managing errors gracefully. Now, you will know right away if your code had any trouble calling the API. Let us see embeddings power a real-life search example. Mini project, semantic search using embeddings. Let us use embeddings to build a simple smart search. You type what you are looking for. The program finds the closest match in our texts. Running the cell now. Let us put this into code next. Now we will build a simple interactive search. You tell the computer what you want, it finds the closest match. This comment reminds us we are taking a user question and searching for the most similar sentence. We ask the user to type what they are searching for. We generate an embedding for their search phrase. We use the same model each time to keep results consistent. We pass in the text from the user. Closes the search embedding request. We compare our search embedding to all existing embeddings. We find which stored embedding is most similar to the search. We print out the text that is most similar to what the user typed. Running the cell now. This output shows the best matching sentence from our texts for the user's search phrase, found by comparing embedding similarities. Notice how the code converts your search into an embedding, then identifies the closest text by cosine similarity, demonstrating how semantic search captures meaning beyond exact word matches. This highlights the power of embeddings to find relevant results based on context, not just keywords. You just built a basic semantic search engine. Try it by typing things like AI company or fruit color. If your code does not work, do not worry. Let us see how to troubleshoot common problems. We add a comment for troubleshooting help. We print a checklist for debugging. Step 1. Make sure you set your API key. Step 2. Check your internet connection. Step 3. Look for typos in any code or model names. Running the cell now. This output provides a troubleshooting checklist to ensure your semantic search code runs smoothly. Notice how it reminds you to verify key setup steps like your API key, internet connection, and correct function names. These are essential for successfully generating embeddings and performing the search. Including these checks helps prevent common errors before moving forward with building the smart search feature. Now you have quick tips for fixing common errors. Time to challenge yourself. Challenge 1. Try your own sentences. Change the text list to use your favorite sentences. Rerun the code and see what embeddings you get. What do you notice when comparing unrelated and related texts? Running the cell now. See if the results make sense for your changes. Let us try another challenge to check our search tool. Challenge 2. Explore with new search phrases. Try typing different search phrases with the semantic search. Can you find different best matches? Try making the text similar or very different and see what happens. Running the cell now. You will get different answers based on how related your sentences are. Let us summarize what you gained from this lesson. Recap what you learned. Set up your OpenAI API connection securely. Created text embeddings and saw what they look like. Compared how similar texts are using vectors. Built a mini semantic search engine. Running the cell now. You now have the basics to explore OpenAI embeddings in more depth. That is it for this lesson. Thank you for joining. Thank you for learning with us. Try the code, change examples, and share your results. Subscribe for more AI tutorials and hands-on beginner guides. Running the cell now. We will see you in the next video.